This video is showing operations on functions. We're going to do the sum, which is addition, difference, which is subtraction, product, which is multiplication, and quotient, which is division of functions. We will also be finding the domain. So to find the domain, we're going to graph the function and see for which x values the function exists. We're going to start with the sum of functions. This says f plus g of x really means that f of x plus g of x. We're going to add the functions together by combining like terms since it still says f plus g of x. We're going to add our functions. So first, I'm going to write down the f of x. And when we're adding, subtracting, multiplying functions, we want to make sure we keep our function group together. So I'm going to keep my f of x inside of parentheses at the beginning. So my f of x is equal to 3x squared plus 7x. Then I'm going to add, I'm going to put g of x also inside of parentheses. So I'll have g of x is 2x squared minus x minus 1, and I'll close my parentheses since that is the end of the function. We want to use the parentheses to determine if anything will need to change when we're adding them. Since there is a positive in front of this set of parentheses, I will distribute a positive, which will not change any of the signs. Therefore, I can just write my f of x down below it without any of the parentheses. So I can have 3x squared plus 7x. There's a positive in front of the second set of parentheses, so when I distribute the positive, it also will not change any of the signs because a positive times a positive remains a positive. A positive times a negative remains a negative. So I can write, we'll have a positive 2x squared, a negative x, and a negative 1. There are no more parentheses. Therefore, I can combine my like terms. I want to find which parts are like terms. You can see that there is an x squared on our 3 and also an x squared on our 2. I'm going to highlight these two. I have a positive 3x squared and a positive 2x squared. I do want to make sure I contain my sign with the 2x squared. I move on to see if there's any more. I have a positive 7x, but then I also have a negative x, so I can combine those as well. I'm going to highlight those. Positive 7x and a minus x. The last term is a minus 1. There are no other terms like that, so I know that that one is going to be alone. So I go ahead and come down to my answer because I can combine our like terms. It's going to be f plus g of x is equal to, I'm going to start with my highest exponents, which are x squared. I have a 3x squared plus a 2x squared. That turns out to be 5x squared. Then I have a positive 7x and a minus x. I do not add the x to the 7 because I am not adding it to the other side of an equal sign. I'm not doing the inverse operation. I'm combining them as they are. This is a positive 7x and a minus x, which turns into be a positive 6x. Then I have the minus 1 at the end, and there's nothing else that will combine with it, so it's just minus 1 at the end. So f plus g of x is equal to 5x squared plus 6x minus 1. Now to determine the domain of this, we're going to graph this function. We're going to graph this function. So I'm going to turn on my calculator. I'm going to go to y equals. I'm going to type in 5x is right here, squared, plus 6x minus 1. Notice I did put a minus sign, not a negative. That is a minus. I'm going to press graph so I can look at this. This is a quadratic, and it is the shape of a parabola. The x's go left and right, and as we see this graph, it will keep going up and to the left, so it does keep going to the left forever. It hits all of these x values, and then as it keeps going up and to the right, it will continue going right forever. The mathematical word for forever is infinity. So our domain is going left forever, that goes to the negative infinities, and then it's going to the right forever, which is the positive infinities. So our domain is negative infinity, comma, positive infinity. This is interval notation. This is saying negative infinity to positive infinity. I have to explain which brackets to use. These are going to use open brackets, which are another word for parentheses, but it's open brackets with domain, because infinity is never actually touched. If it was a number that actually ends, it would be a closed bracket, but this is an open bracket because infinity is never actually touched. So this is negative infinity to positive infinity. Moving on to this one, it's still very similar. It's f plus g, but now it says of 5 instead of x. What that means is that we plug 5 into our f of x and 5 into our g of x. This does not mean that we are multiplying by 5. I'm going to start with the f of x. So the f of 5 is equal to, I'm going to put everywhere in the f of x, everywhere I see an x, I'm going to put parentheses. So I see an x, I'm going to put parentheses, but then I square it, minus 3, I see an x, parentheses, plus 1. Everywhere I see the parentheses, I'm going to input that 5. I'm going to input this 5 into here. This is f of 5. I find out what that value is, so I have 5 squared is 25. 3 times 5 is 15, so this is 25 minus 15, which is 10, plus 1, which is 11. So I have f of 5 is equal to 11. I'm going to do the same thing with the g of 5. Everywhere I see a x, I'm going to put a parenthesis, so I have 4x, which is parentheses, and then plus 5. Inside the parentheses, I'm going to input the 5, and then simplify. 4 times 5 is 20, plus 5 is 25. Now what we do, it says f plus g of 5 is equal to, we're going to take the 11, since it was first, it's f of 5 is 11, plus g of 5, which is 25, so it's 11 plus 25 is equal to 36. This is no longer a function that we're going to graph. The domain, we're not going to worry about this one because this is just asking for a value when x is 5. So I'm going to skip the domain on this section. Moving on to the difference, we're going to do the same setup. We're going to subtract them instead. So as you see, this is f minus g of x, which really represents f of x minus g of x. So on this one it says we're going to subtract f minus g of x. We're going to take our f of x first, and as before, since it is an x, I'm going to combine our like terms. So I want to take my f of x and put it back in parentheses. So I have parentheses 3x squared plus 7x. Then we're going to subtract g of x, so I'm going to continue keeping that in parentheses, 2x squared minus x minus 1. Now we're going to try and get rid of the parentheses by distributing anything that needs to be distributed. In front of this first set of parentheses, the f of x, there is a positive, therefore the signs will stay the same. There's nothing to distribute. So we have 3x squared plus 7x. In front of the g of x, we do have a subtraction sign, and that will distribute inside of everything. So this is one of the important reasons why we have these parentheses, to make sure that if we have to distribute, we do. So when we distribute the negative to the 2x squared, it becomes minus 2x squared. The negative times negative x is a positive x, and the negative times negative 1 is a positive 1. Now that we've gotten rid of the parentheses, we can combine our like terms. I'm going to find my highest exponent, my x squared. There is another x squared, so I'm going to highlight those two. I have a positive 3x squared and a negative 2x squared. Make sure you see what the sign is. Then the next one is going to be the x's. I have a positive 7x and a positive x, so I will make sure I highlight both of those. Positive 7x and a positive x. The 1 is by itself. There is no other constant, so I know that that 1 will remain as plus 1. So I will have parentheses f minus g of x is equal to, start with your highest exponents, 3x squared minus 2x squared, which will become just a positive 1x squared, or just x squared. Then we have positive 7x and positive x, which is a positive 8x. And then our positive 1 plus 1 at the end will remain as plus 1. So f minus g of x is equal to x squared plus 8x plus 1. Now if I were to look at the graph of this again is the same shape as the first one we did because it is an x squared. This is considered a quadratic, and it is a positive quadratic, so it will be an opened parabola, opening up. Parabolas will continue going to the left forever, and they will continue going to the right forever. So the domain here would again be open bracket, negative infinity to positive infinity, open bracket. On this one is saying f of 2 minus g of 3. So we are going to plug in numbers for our x's, because instead of saying f of x, it says f of 2. So I'm going to start with the f of 2 equals. Everywhere on the f of x I see an x, again, I'm going to put a parentheses. So I have parentheses squared minus 3 parentheses plus 1. Now inside those parentheses, I'm going to input the 2. So we have 2 squared is 4, 3 times 2 is 6, so it's 4 minus 6 is equal to a negative 2, plus 1 is equal to a negative 1. So we have f of 2 is equal to a negative 1. Next up, I'm going to do the g of 3. So I'm going to take my g of x, and everywhere I see an x, I'm going to put a parentheses. So we have 4 parentheses plus 5. And inside these parentheses, I'm going to input the 3 since it's g of 3. So we have 4 times 3 is 12, plus 5 is equal to 17. So what we have both of the values now. We're going to take f minus g of our number, so it's going to be f of 2 minus g of 3 is equal to. We're going to take the f of 2, negative 1. We're going to have a negative 1, then minus the g of 3, which is the 17. So it's negative 1 minus 17, which is actually equal to a negative 18. And that's our answer. And again, since this is a value, since we plugged in values in input, output, we are not going to graph this and find the domain, so I'm going to skip the domain on that one. If we go on to the product, which is another word for multiplication, we're going to take f times g of x. So again, I'm going to use parentheses. I'm going to have parentheses. My f of x is the 3x squared minus 2x plus 1 times, so I can put a time symbol here, or I can just open up another set of parentheses that represents the same thing. And then we're going to have g of x, which is x minus 4. There is no operation in the middle here. This is multiplication. You want to distribute everything from the first set of the parentheses into the second set. So we're going to multiply everything from the first set of parentheses to the second set. I will actually, and it doesn't matter if you go first to the second or second to the first because of the commutative property of multiplication. So I'm actually, to make this a little easier, I'm going to do x to 3x squared times the negative 2x and times the positive 1, just to draw my arrows. Then I'm going to take the negative 4 and multiply it to everything as well. So then 3x squared, the negative 2x, and the positive 1. You can also do this in what's called the box method and just multiply in it's a box. So we have 3x squared times x, which is 3x cubed. When you multiply variables, you have to add the exponents. Then we have negative 2x times x, which is negative 2x squared. Then we have a positive 1 times x, which is a positive 1x, or just positive x. We've multiplied everything to the x, so we're going to go on to the negative 4. We have 3x squared times negative 4, which is negative 12x squared. Then we take our negative 2x to multiply to the negative 4, which is a positive 8x. Then we have a positive 1 times a negative 4, which is a negative 4. We have gotten rid of all the parentheses, so now we're going to combine our like terms. Start with the highest exponent. We have a 3x cubed. There's no other x cubed, so I know that one's going to stay as it is. Then we have a x squared, which we do have another x squared, so I will highlight those. I have a negative 2x squared and a negative 12x squared. The next one is x's, and I do have an x here and an x here, so I will highlight those. I have a positive x and a positive 8x. The last thing we have is that minus 4, and again, there are no other constants, so I know that my ending will be of that minus 4. So we have f times g of x is equal to. The highest exponent was that x cubed. It was alone, so I just keep it as 3x cubed. X squared, we have a negative 2x squared minus 12x squared, which is a negative 14. Keep the x squared. Then we have a positive x and a positive 8x, which turns into a positive 9x. And then we have the minus 4 at the end. So our multiplication is 3x cubed minus 14x squared plus 9x minus 4. If we were to look at the graph of this, I'm going to go back to my y equals. I'm going to clear out my original equation. I'm going to type in 3x cubed. To cube it, I'm going to go to this insert key, the caret key, and put a 3. Then I have minus 14x squared plus 9x minus 4. I want to graph this so I can see the shape of it. This is the shape. It's going up, then back down, then back up. This is a cubic function. This graph, again, we're talking about the domain, which is left and right. This graph will continue going down and left, and this part of the graph will continue going up and right. So we focus on the fact that it is going left, it will continue going left forever, and it will continue going to the right forever. So again, just like the quadratics, it was a negative infinity to a positive infinity. Open bracket, negative infinity, comma, positive infinity. This is the same type of function. We're going to multiply them, so we can just follow the same steps that we did on here. I'll move on to the quotient of functions. The quotient of functions is f over g of x, which is the same thing as f of x divided by g of x. The biggest thing you have to remember is that you cannot divide by a 0, so g of x, whatever it is, cannot be equal to 0. Now we're going to focus on having numbers instead of x's because we're not going to simplify the functions. We will be just focusing on inputting the values and getting a number value out of it. So again, since we're dealing with numbers, I'm going to start with the f of x first. So I have f of negative 1. And again, anywhere I see x, I'm going to put parentheses. So it's 3 parentheses squared minus 2 parentheses plus 1. And anywhere I see the parentheses, I'm going to input the negative 1. And we're going to simplify this. Now we deal with the exponents first. Negative 1 squared is a positive 1. So we have 3 times really positive 1. Then we're going to have a negative 2 times negative 1, which is a positive 2. So this is really a 3 plus 2, which is 4, plus 1, which is 5. So this is the value, f of negative 1 is actually equal to 5. Now we're going to focus on the g of negative 1. So g of negative 1, again, everywhere I see an x, I want to put parentheses. So we have x, which is parentheses, minus 4. Anywhere I see the parentheses, I'm going to input the negative 1. So we really have negative 1 minus 4. Which is negative 5. I'm sorry, this was 3 plus 2, which is 5, plus 1, which is 6. I apologize. This was actually supposed to be 6. There we go. So we have, again, this was a positive 1, so 3 times 1 is 3. Then plus 2, 3 plus 2 is 5, plus 1 is 6. Then we have g of negative 1 is negative 5. Now what we're going to do is take our f over g of the negative 1. So we're going to put its f of negative 1 is 6 divided by g of negative 1 is negative 5. So we're going to do 6 divided by negative 5. 6 divided by negative 5 is just negative 6 over 5. And that's our solution. We'll come over here and do the same thing with the 0. So we're going to start with f of 0. Anywhere I see x, I'm going to put parentheses. So parentheses, then squared, plus 5 parentheses, minus 1. And anywhere I see the parentheses, I'm going to input the 0. So 0. So 0 squared is 0. 5 times 0 is 0. So this right here is just 0. Minus 1 is negative 1. Then we have g of 0. Everywhere I see an x, I'm going to put parentheses. So it's 3 parentheses minus 2. Then we're going to input the 0 anywhere we see the parentheses. So 0. 3 times 0 is 0. Minus 2 is negative 2. Now that we have the f of 0 and g of 0, we're going to simplify it. So this becomes f over g of 0. So we're going to have f is negative 1 divided by g of negative 2. So negative 1 divided by negative 2 is a positive 1 over 2. And that is our solution. And again, I'm going to skip over the domain for now because this is a one-number solution instead of a function with x's.